Alrighty, we are back with day 8 of our ACT Prep Unit 4, which is our intermediate algebra topics, and we're talking about patterns, sequences, and modeling today. Okay, patterns, sequences, and modeling. Pascal's triangle is among the most famous patterns in mathematics. Each term in the triangle is the sum of the two terms immediately above it to the left and to the right. This triangle can be used to model probability events, and each row shows coefficients of a power of the binomial x plus 1 cubed. Okay, so we use this to, Pascal's triangle is used to expand binomials. You can also use it to model probability, and what you do is you start with 1, okay, and you drop those, and then you add these. 1 plus 1 is 2, okay, and then again you drop your 1's on the end. To get this number, you have 1 plus 2 is 3, 2 plus 1 is 3, and then the 1 drops. So to get my next row, my 1's drop, and I get 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Drop the 1's. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. It's really a very, very, very cool pattern, okay, but there's a pattern to it. Sequence. A sequence is a list of numbers that follows a pattern. Sequences frequently model events. The square and triangular numbers below form sequences. So we have the triangular numbers, okay, 1, 3, then they made a bigger triangle, which is made up of 6 dots. The next triangle is made up of 10 dots, and you can see the pattern. Here, we're going to add 2 dots to get 3. Here, we're going to add 3 dots to get 6. Here, we're going to add 4 dots to get 10, so guess what the next one's going to be? We're going to add 5, which would make, if I drew it, which I'm not going to try, would be 15. All right, and then we'd add 6, so the next one would be 21, and we could keep going. The next one we would add 7, and so on and so forth. We have the square numbers, 1, 4, 9, 16, and you can find different patterns in these, but this one's kind of cool because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the next one is going to have 5 squared, or 25 dots in it. The next one would have 6 squared, or 36 dots in it. Okay, there's a pattern. There's a sequence. All right, so you can find patterns within sequences. Notice that the sum of two consecutive triangular number yields a square number. The Fibonacci sequence is the most famous mathematics sequence. The first 11 terms of the Fibonacci sequence are shown below. The pattern starts with 1, and then each term is the sum of the two previous terms. So it starts with 1, all right, and then to get this next one, if I add 1 plus 2, I get 3. If I add 2 plus 3, I get 5. If I add 3 plus 5, I get 8. If I add 5 plus 8, I get 13. If I add 8 plus 13, I get 21, and so on and so forth. So you add the first two numbers in front to get the two numbers behind to get the next number in the sequence. Fibonacci numbers model many natural occurrences, including the swirls found in pine cones and the number of petals on sunflowers. The quotient of two consecutive Fibonacci numbers approximates the golden ratio, which is 1.6. This ratio is often found in nature and architecture. This is the golden ratio right here. Okay, there's the golden ratio. There's the golden ratio. There's the golden ratio. Hurricane. There's the golden ratio. There's the golden ratio. There's the golden ratio. Okay, they're everywhere in nature especially. It's pretty cool actually. All right, so arithmetic sequences. In an arithmetic sequence, consecutive terms differ by the same amount called the common difference, or we call it D. Example, 3, 5, 7, 9, 11 is an arithmetic sequence with a common difference of 2 because 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. 11 minus 9 is 2, which means the pattern is there's a common difference of 2, which means to get the next one, I'd add 2. So the next term would be 11 plus 2, which would be 13. The next one would be 13 plus 2, which is 15. And you could keep the sequence going forever and ever and ever. Okay, this one's an arithmetic sequence, but now we're going down, so the common difference is -3, because 7 minus 10 is -3. 4 minus 7 is -3. 1 minus 4 is -3. -2 minus 1 is -3. So to get the next one, I would do -3. -2, the next one would be, you would add -3. So -2 plus -3 would be -5, and so on and so forth. All right, the general term of an arithmetic sequence is given by this formula, a sub n. In other words, to get the next term in the sequence, you take the very first term in the sequence, and you add your common difference, take away 1. I mean, the number, the term that you're looking for, take away 1, times the common difference. And yeah, a sub n is the nth term. A sub first one is the first term. N is the position in the sequence. And D is the common difference. All right, oops. Geometric sequence. In a geometric sequence, consecutive terms vary from each other by a factor called the common ratio, or R. This is a geometric sequence with a common ratio of 2. And what you do is you just divide backwards. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. The common ratio is 2. So to get the next one, we would multiply by 2. 48 times 2 would be 96. 96 times 2 would be 192, so on and so forth. Okay? 36 has this 36, 12, 4, 4/3, 4/9 is a geometric sequence with a common ratio of 1/3. If I divide 12 divided by 36, that's 1/3. 4 divided by 12 is 1/3. 4/3 divided by 4, if you keep, change, flip, is 1/3. So on and so forth. So to get the next one, we'd multiply by 1/3. So my next one would be 4 over 27. And then we'd multiply by a third again and again and again and again. Okay, this one has a common ratio of -4 because -4 divided by 1 is -4. 16 divided by -4 is -4. -64 divided by 16 is -4. So to get the next one, we would multiply by -4. And then there's your general term for a geometric sequence. Okay? All right, you try this one, hit pause, come back when you're ready. And hopefully you got E. It says Greg went to the duck pond every day for a week. The table shows the number of ducks Greg saw each day. If this pattern remains the same, how many ducks will George see on the 11th consecutive day he goes to the duck pond? Well, we got to figure out the pattern. All right, if I try adding, I'd be 2 plus 2 is 4, plus 2 is 6. So it's not addition because the next number is 8. So if it's not arithmetic, try geometric. What would I multiply by? 2 times 2 is 4, times 2 is 8, times 2 is 6. The pattern is multiplying by 2. So on day 7, we have 128. We want to know on day 11, 7th, 8th, 9th, 10th, 11th. So I'm going to keep multiplying by 2. All right, so I got 128 times 2 would be 256. Times 2 would be 512. Times 2 would be 1024. Times 2 would be 2048. Okay, and we could have used the formula. We could have said the nth term is going to be the first term, which is 2, times my common ratio, which is 2, to the n minus 1, which they want the 11th term. So if I make that 11, then it's 2 times 2 to the 10th, which then if you type that in, you get 2048. But again, sometimes to remember the formula in arithmetic and geometric sequences, it's not very common. So it's not a formula that's, easily remembered because we just don't use it very often. So to me, unless they were asking like for something like how many ducks would he see like on the 500th day? Okay, now I don't want to keep multiplying by 2 500 times. So then I'd use I'd hopefully have the formula. But again, if they're not asking for very very far out, just find the pattern and keep extending it. All right, so they want me to write the next 3 terms in each sequence. All right, well, it's looking like they did 5 and then 5 and then 10 and then 15 and then 25 and then 40. So I'm trying to figure out what the heck the pattern is. And I get, if I ignore this first one, 5 plus 10 is 15. 10 plus 15 is 25. Okay, so it looks like what they're doing to get the next term, 10 plus 15 is 25, 15 plus 25 is 40, 25 plus 40 is 65. And guys, one thing that's irritating about sequences is if it's not arithmetic or geometric, then it's not an easy pattern to find. If it's arithmetic, then the common difference is easy to see. They're adding the same thing every time. Well, you can see they're not adding the same thing every time, nor are they multiplying by the same thing every time. So when it's not arithmetic and it's not geometric, you just kind of have to play with it until you find a pattern. I'm old, so I've learned that for some reason, one of the common patterns is Fibonacci sequence, in which you add the 2 before to get the next one in line. Okay, so to continue this sequence, to get this term, I'm going to add the 2 in front of it. So 40 plus 65 would be 105. And then, excuse me, 65 plus 105 would be 170. And 105 plus 170 would be 275. Those would be the next 3 terms in my sequence. Okay, on 2, again, I always check for arithmetic or geometric first. Excuse me. And to check for arithmetic, subtract. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5, it's the common difference is 2. So they're adding 2 every time. So for me to get the next 3 terms, I keep adding 2. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. Okay. All right, and number 3, 97, 86, 75 is going down. So again, I'm going to see if it's arithmetic. If I do 86 minus 97, I get negative 11. If I do 75 minus 86, I get negative 11. So it looks like my common difference is negative 11. So to get the next 3 terms, I subtract 11. So 53 minus 11 is 42. 42 minus 11 is 31. 31 minus 11 is 20. And those would be my next 3 terms. Okay. All right, for 4, again, I'm going to see if it's arithmetic. 3 minus 1 is 2. 4 minus 3 is 1. It's not arithmetic. If I try geometric and divide, 3 divided by 1 is 3. 4 divided by 3 is 0.75. Those are different, so it's not geometric, which means it's some other pattern altogether. Again, try the whole adding thing. 1 plus 3 is 4, check. 3 plus 4 is 7, check. 4 plus 7 is 11, check. So they're adding the 2 in front to get the next one. So to get my next term, I'm going to add 29 and 47. which would be 76. Okay, to get my next one, I'm going to take 47 plus 76, and I get 123. And to get my third one, I'm going to take 76 plus 123, which is 199. Okay. All right, number 5, I'm going to try arithmetic. 8 minus 3 is 5. 13 minus 8 is 5. 18 minus 13 is 5. So my common difference is 5. So to get my next 3 terms, I'm going to add 5. 23 plus 5 is 28. 28 plus 5 is 33. 33 plus 5 is 38. Okay, on 6, some color in here. It ain't arithmetic. 8 minus 1 is 7. 27 minus 8 is not 7. It's not geometric. 8 divided by 1 is 8. 27 divided by 8 is not 8. So I got to find a pattern. And I'm going, it's not adding. 1 and 8 don't make 27. So again, because I'm old, it's not that I'm that smart, I'm just old, and I've had to look at patterns in a long time. I always then try squares, cubes, square roots, cube roots, and it looks to me like, okay, again, just because I'm old, these look like cubes to me. 1 cubed is 1, check. 2 cubed is 8, check. 3 cubed is 27, oops, check. 4 cubed is 64, so they're just cubing. 5 cubed is 125. So to get my next 3, I'm going to do 6 cubed, which is 216, then 7 cubed, which is 343, and 8 cubed would be 512. Okay? All right, on this one, if I try arithmetic, 1,000 minus 2,000 would be negative 1,000. 500 minus 1,000 would be minus 500, so it's not arithmetic. Try geometric. 1,000 divided by 2,000 would be 1/2. 500 divided by 1,000 would be 1/2. 250 divided by 500 would be 1/2. So my common difference is 1/2, or, if you will, dividing by 2. So to get my next term, I'm going to do 125 divided by 2, which is 62.5. To get my next one, I'm going to divide by 2 again. 62.5 divided by 2 is 31.25. And to get my last one, I'm going to take 31.25 and divide by 2 again, and I get 15.625. Okay? All right, number 8, I'm looking. 6 minus 2 is 4. 18 minus 6 is 12. It's not arithmetic. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So my pattern is they're multiplying by 3. So to get my next one, I take 486 times 3 is 1458. 1458 times 3 is 4374. And 4374 times 3 is 13,122. Okay, number 9, I'm going to check for arithmetic first. 31 minus 39 would be negative 8. 23 minus 31 is negative 8. Ugh. So they're going down by 8 every time. So to get my next term, I'm going to do 7 minus 8, which is negative 1. Negative 1 minus 8 is negative 9. Negative 9 minus 8 is negative 17. Yeah? Okay? Alright, so on this one, 2, 3, 5, this one is weird. I actually had to Google this. I couldn't find the pattern to save my life. And for near as I can tell, sometimes you have to ignore the first few and focus on, because like 2 to 3, I'm thinking, well, they added 1, and then they added 2, and then they added 4, but then they added 4, and then they added 2, and then they added 4 again, and then I can't figure out the pattern. Nothing really makes sense, and it's not geometric, clearly. So when I Googled it, I guess I could have looked in the ACT book, but when I Googled it, it said, if you ignore these, okay, and you take 5 and you add 6, that's 11, which isn't the next term, but it's this term. So what if I take 7 and I add 6? I get 13, which isn't the next term, but it's the one after. So what if I take 11 plus 6? That's 17. It's not the next one, but it's the next after. So what that says is, if I want to get my next term, I don't add 6 to the one in front of it. I add 6 to the one before the one in front of it. Does that make sense? So to get my next one, I'm going to take 17 plus 6, which would be 23. Right? So that'd be there. To get my next one, I'm not going to take 23 and add 6. I'm going to take the one in front of it. So 19 plus 6, and that would be 25. Oh, I can't find it. There it is. And then, so that would be my next one. And to get my next one, I don't take 25 plus 6. I do 23 plus 6, which is 29. And I should have looked in the ACT book to check his answer, but that's the one Google came up with, which is the only one that makes sense to me. All right, on 11, it looks like they're adding 2, adding 2, adding 2, adding 2. So they're just counting by 2. So my next one's going to be 12, then 14, then 16. All right, on 12, I could try arithmetic. 2 minus 1 is 1. 4 minus 2 is 2. Nope, it's not arithmetic. Geometric. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. The common ratio is 2. So to get my next one, I multiply by 2. So 32 times 2 would be 64. To get the next one, take 64 times 2 is 128. To get the next one, take 128 times 2 and you get 256. All right, 3, 6, 12, 24, 48. If I try subtracting, 6 minus 3 is 3. 12 minus 6 is 2. Doesn't match, it's not arithmetic. Try division. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. The common ratio is 2. So to get my next 3, I'd multiply by 2. 48 times 2 is 96. 96 times 2 is 192. 192 times 2 is 384. Okay. Again, on 14, if I look, I can't, it's not arithmetic. 4 minus 1 is 3. 9 minus 4 is 5. It's not geometric. 4 divided by 1 is 4. 9 divided by 4 is not 4, so it's not geometric. So you got to look for a different pattern. Some of the common ones are adding the 2 in front to get the next one, squares, cubes. Oh, squares. 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. So to get the next 3, the next one's going to be 6 squared, 36. Then 7 squared, 49. Then 8 squared, 64. And those would be my next terms. All right, here it looks like they're keeping the 1 the same, and they are doubling the bottom. 2 times 2 is 4, times 2 is 8, times 2 is... So to get the next 3, I'm going to multiply the denominator by 2. So 1 over 32 times 2 would be 1 over 64. 1 over 64 times 2 would be 1 over 128. 128... times 2 would be 1 over 256. Alright. On this one, looks like they're going down, so I'm going to try arithmetic. 11 minus 15 would be negative 4. 7 minus 11 would be negative 4. 3 minus 7 would be negative 4. So they're subtracting 4 every time. So to get my next 3, I take negative 1 minus 4 would be negative 5. Negative 5 minus 4 would be negative 9. Negative 9 minus 4 would be negative 13. This is the same one on the other page. To get the next one, you don't add 6 to the one in front, but the one in front of that. So 7 plus 6 would be 13. To get the next one, you add 6 to the one in front. 11 plus 6 is 17. And then the one in front, 11, I did that one. 13 plus 6 would be 19. All right, on 18, looks like, again, I know fractions bother you, but just look up here. 1 times 3 is 3. 3 times 3, they're multiplying by 3. So to get my next 3, I'm going to take the last one and multiply by 3 is 27. 27 times 3 is 81. 81 times 3 is 243. Excuse me. All right. This one's not arithmetic and it's not geometric. I tested. So I'm looking for a pattern. Well, I happen to notice that you add 2. 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 16 is 31. So it looks like they're upping by a double of what they upped by last time. So the next one is I'm going to take 31 and add 32, which would be 63. So then I'm going to take 63, I'm going to double 32, which would be 64, and that gives me 127. I'm going to take 127 and add double 64, which is 128, which gives me 255. Okay? Now, on this one, too, I was like trying to figure out a pattern. How do you go back from whole to fraction? And then I started noticing the pattern of the whole numbers and the pattern of the fraction. The whole numbers are counting by odds. 1, 3, 5, 7. The fractions are going up by 2 every time on the bottom. So my next one would be 1/8. And then the next odd number would be 9. And the next fraction would be 1/10. And those would be my next 3 terms. Okay. All right, try this one. Hit pause. Come back when you're ready. And hopefully you got 120. Gary swims every week. The table shows the total amount of time Gary swims in 5 consecutive weeks. If this pattern continues, how long will Gary swim in the 6th week? Well, I'm thinking arithmetic, or I'm going to try anyway. It's easiest to test. 84 minus 75 is 9. 93 minus 84 is 9. 102 minus 93 is 9. So my pattern is it's going up by 9. So for week 6, I add 9, and that gives me 120 minutes. Okay, hit pause. Come back when you're ready. And hopefully you got G. The first term in a geometric, which means they're going to multiply, sequence is 3, and the common factor is 2. They want to know which of the following shows the first 5 terms in the sequence. 1, 2, 3, 4, 5. Well, if your common ratio or factor is 2, they're telling you to get the next one, you multiply by 2. 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. Okay, try this one, hit pause, come back when you're ready. And hopefully you got D. Alright, on this one it says, which of the following choices displays the 7th term in the sequence below? Well, this is getting big fast, so I'm thinking not arithmetic, but geometric. 32 divided by 4 is 8. 256 divided by 32 is 8. 2048 divided by 256 is 8. So they're multiplying by 8 every time. And they want the 7th. 1, 2, 3, 4, 5, 6, 7. So multiply by 8, and I get 16384. Multiply by 8, I get 13107.2. Multiply by 8, I get 1048576. Okay. All right. Try this one. Hit pause. Come back when you're ready. And come on. Hopefully you got H. It says 81 is the 9th term in which of the following sequences? Well, if I expand this out, 1 to 3 is add 2, 3 to 6 is add 3, 6 to 10 is add 4, 10 to 15 is add 5. So to get the next one, I'd add 6 would be 21, add 6 would be 27, and we want 1, 2, 3, 4, 5, 6, 7, 8, 9. Add 6 is 33, add 6 is 39, and that's not 81, so he's out. Okay, my 11, 21, 31, 11, 21, 31, 41, 51, they're just counting by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 61, 71, 11, 21, 31, 41, 51, 61, 71, 81, 91. Nope, not 81 there. So 2's out. Okay, this one is my squares, if you remember. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 9. 6 squared would be 36, 7 squared would be 49, 8 squared would be 64, and 9 squared would be 81, which puts it in the 9th position, which means that's my solution. Okay. Try this one, hit pause, come back when you're ready. Hopefully you got B. It says, what are the next 3 numbers in this sequence? Well, if I'm trying for arithmetic, 2 minus 1 is 1, 4 minus 2 is not arithmetic. Geometric, 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by it's 2. So to get the next ones, we double, we multiply by 2. So 16 times 2 is 32, times 2 is 64, times 2 is 128. Okay? Oh, and we are done. So I will see you next time for day 9.